We're doing this mission to prove that we can deflect an asteroid.
5, 4, 3, 2, 1. And liftoff of the Falcon 9 and DART on NASA's first planetary defense test.
NASA chases asteroids for two big reasons. They're exciting, and they're important for safety and science. But now there is a third one. A massive asteroid may be coming to Earth at a devastating speed. That's why they just studied the inside of one small visitor. Recent finds show chemicals that could have the origins of alien life. But what if these space rocks have even more mysterious secrets that could change our understanding of DNA? Let's explore our striking similarities to aliens. The asteroid connection. NASA's efforts to chase down these hurtling rocks aren't just for fun, it's serious business. Think of it as throwing a machine into the vast empty space, aiming at a tiny fast-moving rock. It's almost like trying to catch a speeding bullet with your bare hands. But NASA did just that. They sent a spacecraft to one of these roaming asteroids, a small dot in the vast universe, hoping not just to reach it, but to grab a piece and bring it back for examination. The excitement around the spacecraft's return was huge, mixed with a touch of fear. Stories about asteroids usually involve destruction. They're often seen as giant bombs floating in space, ready to crash into Earth. However, the samples brought back at the end of 2023 surprised everyone. Scientists were expecting to learn maybe how to protect the planet or what minerals these space rocks held. But they found something unexpected that could be even more important. The tests on the asteroid pieces suggested something amazing. The chemicals found inside might be similar to those that started life itself. This discovery could change our understanding of life in the universe. It suggests that life might not be unique to Earth, but could be common across the cosmos, possibly starting in similar ways on different planets. But these findings also raise big questions. If life can travel on asteroids, does that mean Earth's life came from space? And if so, are we alone, or is the universe filled with life, spreading from planet to planet? These questions are now driving new scientific studies, as researchers try to understand not just where we come from, but also our place in the universe. Meanwhile, the threat from asteroids hasn't gone anywhere. While they might be the ancient delivery systems of life, they could also cause massive destruction. This duality makes studying asteroids even more important. We need to know more about them, not just to satisfy our curiosity, but to protect our world. When we talk about asteroids, we often hear about them as ancient relics that have floated through space since the beginning of our solar system. They're sometimes described as keys to unlocking the past, holding essential materials that might have helped kickstart life on Earth. But it's important to remember that these space rocks are not just peaceful space travelers. They also pose a real threat to our planet. Scientists spend a lot of time studying meteorites, which are pieces of asteroids that have crashed into Earth. By examining these chunks of rock, researchers can learn about the early days of our solar system and how Earth formed. This information is not just interesting for its own sake. It helps us understand more about where we come from and justifies spending a lot of money on space missions. However, some might question whether all this research and spending are as focused on public good as we are led to believe, or if they're partly driven by the desire to achieve something spectacular. Moreover, there's a popular idea that asteroids might have brought the ingredients necessary for life to Earth. Imagine these rocks traveling through space, carrying elements like carbon and water, and then crashing into young planets, depositing the building blocks of life. This scenario is often used to attract funding and public interest. But while these impacts might have delivered life's building blocks, they could just as easily wipe out all life forms, like what likely happened to the dinosaurs when a massive asteroid struck Earth. The irony here is thick. The very objects that might have helped create life could also destroy it. This threat is why organizations like NASA spend so much time and resources tracking asteroids that come near Earth. They're trying to figure out how to push these potential destroyers away from our planet. This might sound like something out of a science fiction movie, and indeed the dramatic potential of such missions captures a lot of public and political attention. However, there's an argument to be made that we tend to focus too much on these big dramatic solutions and not enough on the steady, less glamorous work of simply keeping track of these space rocks. The global interest in asteroids as the creators and destroyers of worlds feeds many space missions and scientific studies. Yet this focus sometimes overshadows the need for a more practical, everyday approach to dealing with these objects. While we prepare for blockbuster movie-style missions to deflect an incoming asteroid, the quieter task of cataloging and understanding these objects often doesn't get the same level of attention or urgency. As we continue to explore these remnants from the birth of the solar system, the stories we tell about asteroids shape how we conduct our scientific pursuits and how we view our place in the universe. Are we just lucky survivors in a cosmic shooting gallery? Or are we actively shaping our destiny by using science to understand and counter these potential threats? This question isn't just academic. It affects how we plan our space missions and our global defense strategies against possible future impacts. Understanding and preparing for asteroid impacts is crucial in this game of cosmic chance. We need to balance our fascination with their potential to unravel the past and spark life with the practical need to protect our planet. The discussions and decisions around this issue involve scientists and all of us, as the outcome affects the entire planet. The narrative around asteroids is full of contrasts and complexities, and it's vital we manage these with care and attention to ensure our survival in the vast universe. Let's see what treasures and dangers asteroids hold. The last promise of Osiris Rex. Asteroids are often seen as dangerous objects hurtling through space, but they're not just threats. Many of them are actually treasure chests floating in the cosmos. These space rocks are rich in precious metals like platinum and nickel, far surpassing the amounts we have on Earth. As our space exploration technology improves, the idea of mining asteroids is moving from science fiction to a real possibility. Experts are considering how these space resources could not only help future space missions, but also provide additional resources for Earth, which is running low on some materials. This potential is why NASA launched the Osiris Rex mission, an ambitious project aimed at exploring and collecting materials from asteroids. The mission began with a launch on September 8, 2016, targeting the near-Earth asteroid Bennu. The goal was ambitious: land on Bennu, grab samples from its surface, and bring them back to Earth. The mission also planned for extended studies of other asteroids later on. Osiris Rex reached Bennu on December 3, 2018, and began a detailed survey of the asteroid. It measured Bennu's weight and size with great accuracy and managed to enter orbit around it. On December 31, 2018, it successfully collected samples from Bennu's surface. These samples were returned to Earth on September 24, 2023. They are expected to provide valuable data about the conditions of the early solar system and could even hold clues about how life started on Earth. But why choose Bennu from the thousands of asteroids close to Earth? Bennu was selected for practical reasons. Its orbit around the Sun is similar to Earth's, making it easier to reach. It completes its orbit every 436 days and comes very close to Earth every 6 years. Bennu is also quite large, about 1,650 feet wide, which provides a stable surface for landing and operations. Its size and orbit make it a relatively safe and practical choice for a mission of this complexity. Choosing Bennu highlights a trend in our space activities, combining scientific exploration with the search for valuable resources. These missions are not just about understanding space, but also about finding new ways to sustain our activities in space and on Earth. However, as we develop technologies to extract these resources, we must think about the long-term effects. Just as we have learned on Earth, space should not be seen as an endless resource for us to use without consideration. We must approach space mining thoughtfully and responsibly, ensuring that we manage these space resources without causing harm. The Osiris Rex mission is an example of how our ventures into space are evolving. We're not just looking to explore, we're also looking to utilize what we find. However, the debate continues about whether it is ethical and sustainable to mine asteroids. As we push the boundaries of what's possible in space, we need to be mindful of our responsibilities as stewards of both Earth and space. This approach will help ensure that we can continue exploring and benefiting from space responsibly and sustainably. Although Bennu orbits close to Earth and is labeled as potentially hazardous, NASA has calculated that the chance of it hitting Earth by the year 2300 is quite low, with odds of about 1 in 1,750. If Bennu were to hit Earth, the impact would cause a lot of damage to the local area where it lands, but it wouldn't be enough to wipe out all life on the planet. Experts say that the damage would be very bad locally, but overall, Earth would survive. This situation would provide a real-world test for scientists to apply their theories and responses to such an event. The recent DART mission by NASA, where a spacecraft was intentionally crashed into Dimorphos, a smaller asteroid, to change its orbit, shows that we are getting better at potentially steering dangerous asteroids away from Earth. The mission was very successful, achieving more than expected by shortening the orbit of Dimorphos by 32 minutes, proving that this kind of asteroid redirection can work. Back to Bennu, the Osiris Rex mission brought back samples from the asteroid that have provided exciting insights. These samples were found to contain a large amount of carbon, making up nearly 5% of their total weight in both organic and mineral forms. Additionally, water was discovered within the clay minerals in the samples. These findings were made using sophisticated equipment like electron microscopes and X-ray machines, which allowed scientists to look closely at the composition of the asteroid material. NASA's excitement about these findings was clear when they shared that this is the largest carbon-rich asteroid sample ever returned to Earth. Although some might view the dramatic presentation of these findings as a way to secure more interest in funding for space research, the importance of understanding our solar system and how life on Earth might have started cannot be understated. The possibility that life on Earth could have origins connected to materials delivered by asteroids like Bennu adds a layer of significance to these space missions. While the romantic notion of life coming from space may seem like something out of a science fiction story, these missions and their findings provide important clues that help scientists piece together the history of our planet. As investigations into the samples from Bennu continue, they may reveal even more about the early conditions of Earth and how life might have started here. These ongoing studies not only satisfy human curiosity about our origins, but also highlight the practical benefits of understanding asteroids better. Benefits that could be crucial if we ever need to prevent an asteroid from hitting Earth. The combination of scientific inquiry and practical application in these space missions showcases our growing capability to explore and manipulate our cosmic environment. Now that the samples are here, let's find out what secrets they reveal. Fragile minerals and space's stories. The popular idea that comets, asteroids, and meteorites brought the key ingredients for life to a young Earth has captured the imaginations of scientists for a long time. NASA recently announced that the asteroid samples they've collected will be the focus of intense study for many years to come. They believe these studies could teach us about how our solar system formed, suggest how the building blocks of life might have arrived on Earth, and even offer strategies for avoiding catastrophic asteroid impacts in the future. Daniel Glavin, a senior NASA scientist, enthusiastically described the asteroid material as a dream come true for astrobiologists because it's packed with organic compounds. However, there was a twist at the announcement event. No one got to see the actual samples. They were kept out of sight, and attendees had to be content with just photographs and videos. These glimpses were all they had of what's kept under tight security in a new lab at the Space Center, where only a few scientists in special protective gear can access it. The samples that were visible, described as small, dark-colored rocks, pebbles, and dust, were not even the main attraction. They were just what was left over in the outer part of the spacecraft's storage canister. The main sample is still secured away, with technicians working carefully to open the container that holds it. Dante Loretta, the main investigator of the mission, emphasized that the real valuable material is yet to be studied. The initial examination of these leftover bits revealed iron minerals that usually form in water, which wasn't particularly shocking, but still interesting. More intriguing was the discovery of magnesium phosphate in the sample. These white particles are so uncommon in materials from space that Jessica Barnes, an assistant professor at the Lunar and Planetary Laboratory and head of the phosphate analysis, initially thought they might be a mistake. She noted that there are no similar chemicals on Earth, suggesting that the mineral is too delicate to make it through our atmosphere, or doesn't last long once it lands. At a science conference in Texas, Barnes mentioned that these findings indicate various geological activities on the asteroid's parent body, but the mineral's fragility makes it hard to study further. This could make some wonder if we're missing out on other important clues from space because they don't survive the journey to Earth. Additionally, the finding of glycine, a very simple amino acid, in the samples was highlighted as a major discovery. While this could support the idea that the ingredients for life came from space, one has to ask if we're too quick to fit such discoveries into existing theories. Is the significance of finding glycine being overstated? Are we too eager to see it as proof of how life started? NASA's story about these asteroid samples suggests a universe filled with complex beginnings and potential disasters that we might avoid with the right knowledge. However, beneath this exciting narrative, there's a lot of careful control over how much information is shared and how it's interpreted. The strict security and protocols not only keep the samples clean, but also may slow down the rush to conclusions that could disrupt established theories. As we wait for more information to be released about these cosmic samples, one might wonder whether the revelations will truly open new doors to understanding or merely reinforce what we already suspect. The unfolding of these discoveries could either lead to significant breakthroughs or confirmations of what we've long believed about our place in the cosmos. At numerous scientific conferences, researchers have highlighted the presence of water-altered compounds called phyllosilicates, alongside a diverse mix of other organic and hydrated minerals. These phyllosilicates, which are tightly linked with water, are often touted as potential starting points for organics and water that might have come to Earth in its early days. This idea, while captivating, seems to stretch a bit too far, suggesting these tiny components played a major role in the origins of life, a hefty claim for such small particles. At the Natural History Museum in London, Sarah Russell noted one of the sampled fragments as uniquely beautiful and unlike any meteorite in their collection. This comment, meant to impress, subtly points out that while the sample stands out, it's not in extraordinary ways, since extraterrestrial samples are naturally expected to be different from those found on Earth. Over in Washington, D.C., Tim McCoy from the Smithsonian praises the pristine condition of Bennu's fragments. Since these pieces haven't been touched by Earth's atmosphere, they are said to offer a clean snapshot of outer space. Yet one could argue that the excitement about their untouched state is perhaps overstated, as their real value, beyond just being uncontaminated, is yet to be fully demonstrated through concrete scientific achievements. In Arizona, Andrew Ryan describes many of Bennu's catalog stones as large, rough boulders with a texture like sandpaper. Although this description is vivid, it doesn't particularly shock anyone familiar with space rocks, since it perfectly matches what was expected from earlier remote sensing data from the Osiris Rex mission. Harold Connolly's comments about the accuracy of this remote sensing mainly serve to congratulate existing technology and theories, which, while reliable, don't really expand our knowledge of the universe. This thorough examination and analysis, aligning with the dominant theory that Bennu broke off from a much larger asteroid between 2 billion and 700 million years ago, seems like watching a replay rather than experiencing something new. Even the finding of impact-related breccias, rocks stuck together like pebbles in concrete, doesn't offer much new insight. It's somewhat ironic. The more we confirm what we think we know, the less we discover what we don't know. Are these cosmic clues truly groundbreaking or just familiar echoes? A new chapter in asteroid research. In reflecting on these discussions and findings, it becomes clear that the enthusiasm for the samples might overshadow the fact that much of what is being celebrated is confirmation rather than revelation. The discussions about the pristine and uncontaminated nature of the samples, their interesting textures, and their alignment with previous hypotheses might benefit from a shift towards questioning and exploring what these elements might really tell us about the universe that we still do not understand. By re-evaluating our approach to these celestial findings, the scientific community could potentially open new pathways for exploration and discovery that go beyond merely confirming the expected. It's essential to foster a culture of scientific inquiry that embraces not only the validation of old ideas, but also the pursuit of new ones. Only then can we truly expand the frontiers of our cosmic knowledge and perhaps find truly surprising insights about our universe. Tim McCoy explained that these features originally formed on a different, larger asteroid and later became part of Bennu as boulders. Yet when exactly this happened is still not clear. McCoy openly admits that they are just beginning to scratch the surface of this detailed research, acknowledging that there's a lot they don't yet know. The exploration of Bennu is made possible by 5 sophisticated instruments on the spacecraft, each designed to study and detail the asteroid in its own unique way. First, there's the Osiris Rex visible and infrared spectrometer, known as OVIRS. This instrument is crucial because it searches for organic materials and minerals by analyzing the light visible to our eyes and the light in the near-infrared spectrum, which we can't see. By studying the light reflected off Bennu, OVIRS tries to pick up hints about what the asteroid is made of. Next in line is the Osiris Rex Thermal Emission Spectrometer, or OTS. This tool measures the heat coming from Bennu to determine its temperature and to help map out what minerals and chemicals are present. OTS works closely with OVIRS by combining their data to better understand the asteroid's composition and to choose the best spots to collect samples from. The third major tool is the Osiris Rex Camera Suite, or OCAMs, which is actually a set of 3 cameras. Each camera has a specific role in mapping and examining Bennu. Polycam, the biggest camera, started its job when Bennu was still 1.2 million miles away from the spacecraft, snapping the first close-up pictures of the asteroid. MapCam looks for tiny moons and dust around Bennu, captures Bennu in full color, and takes images used to create detailed maps of the asteroid's surface. SAMCAM focuses on recording the sample collection process, making sure every step is documented. The fourth instrument is the Osiris Rex Laser Altimeter, known as OLA. OLA's job is to scan the entire surface of Bennu and send back data that are used to create very precise 3D models of the asteroid. Despite facing some setbacks, such as one of its 2 lasers built in Canada failing during the primary mission, OLA continued to work longer than expected and gathered all the needed data. These instruments together tell a story of not just scientific pursuit, but also of technological ambition and the challenges that come with it, yet filled with practical difficulties like equipment failures and the unpredictable nature of space objects. The information they collect helps to piece together Bennu's story, but as McCoy mentioned, understanding Bennu is a complex and ongoing task. The truth about how Bennu's features came to be is tucked away in the data being slowly and carefully analyzed by scientists, revealing the asteroid's history bit by bit. As they push forward, the researchers hope to uncover more about Bennu's past, helping us understand not only this particular asteroid, but also the broader universe. NASA's Osiris Rex mission is doing more than just visiting asteroids. It's examining them with a special tool called the Regolith Ray Imaging Spectrometer, known as REXIS. This instrument is crucial because it doesn't just take pictures. It analyzes the asteroid Bennu's surface to find out what elements are there. It's like a scientist in space, figuring out what Bennu is made of, one atom at a time. But NASA's plans don't stop with Bennu. They're already planning the next step of this space adventure with another asteroid, Apis. Apis was once considered a risky asteroid because it might hit Earth, but recent studies have taken it off the danger list, saying it won't be a problem for at least the next 100 years. This decision was based on better tracking and understanding of its path around the Sun. On April 13, 2029, Apis will come very close to Earth, closer than the satellites that orbit our planet in geostationary orbit. Initially, scientists thought Apis might crash into Earth in 2068, but they've since figured out that it won't happen. NASA's choice to send Osiris Rex to visit Apis after it finishes with Bennu feels a bit like they're making the most of the equipment they've already paid for and sent into space. They're using Osiris Rex for one more mission because it's already out there and capable. It's practical and saves money, sure, but it also shows how NASA likes to use every chance they get to learn more about space. Looking ahead, what new discoveries will our next missions bring? A savage competition for cosmic clues. In 2022, when NASA announced that they would be redirecting Osiris Rex to fly by Apis, it was a move that showed both careful planning and a bit of clever resourcefulness. There's a real benefit to checking out Apis up close, especially since we once thought it could hit us. By studying it, NASA can learn more about its composition and behavior, which is essential for understanding these floating rocks in space. The mission to Apis is not just about taking a closer look. It's about continuous learning and preparation. Every piece of data helps us understand the bigger picture of our solar system. It's about staying ahead, being prepared, and maybe one day being able to prevent a potential disaster from an asteroid impact. This extended mission of Osiris Rex shows how space exploration is evolving. It's not just about reaching new places, but also about making smart, strategic decisions that help us learn more while being budget conscious. By sending a spacecraft that's already in space to a new target, NASA demonstrates how forward-thinking and adaptive it can be in its quest to uncover new information about the objects that share our solar system. This approach not only maximizes the return on investment in space tech, but also keeps pushing the boundaries of what we know about the universe around us. As we continue to explore outer space, NASA's Osiris Rex spacecraft, freshly renamed Osiris Apex after dropping off samples from asteroid Bennu, sets its sights on a new target, Apis, expected to be reached by 2029. The renaming might seem like a trivial change, but it underscores the ongoing saga of rivalry and competition in the space exploration sector, where the challenges are immense and the funding astronomical. The change to Osiris Apex is a subtle nod to NASA's efforts to stay in the limelight of asteroid sample returns. While it boasts of Osiris Rex being the first U.S. mission to bring back asteroid samples, it's essentially playing catch-up with Japan. The Japan Aerospace Exploration Agency has already accomplished similar feats twice. Their Hayabusa missions in 2010 and 2020 successfully returned samples from asteroids Itokawa and Ryugu, respectively, showcasing Japan's lead in the pursuit of these space rocks. This race to collect bits of rock from space might seem like an overly expensive cosmic scavenger hunt, but there's a bigger picture. These missions are about more than just national pride or collecting space rocks for display. They aim to help us understand how life might have started on Earth, potentially brought here by these rocky travelers from space. Now, as Osiris Apex gears up for an 18-month close examination of Apis, the spacecraft boasts a set of fully operational instruments, save for one faulty transmitter. But let's focus on the real capability, getting close enough to another asteroid to study it in detail. If past missions have shown us anything, it's that these close encounters are as much about showing off technological capabilities as they are about genuine scientific discovery. Alongside its primary mission, Osiris Apex will also look into the Yarkovsky effect, a subtle but important phenomenon where sunlight nudges asteroids, slowly but surely altering their trajectories through space. Though this effect is small, over millions of years, it could change an asteroid's path significantly, possibly turning a distant rock into a potential threat to Earth. Understanding this effect is crucial, not just for academic reasons, but as a practical measure to protect Earth. Do these missions truly advance our understanding? Or are they just grand displays of human ambition? Like, comment, and subscribe to join the discussion and share your thoughts.